Hello, today we'll be working on question 8.14 in homework chapter 7 and 8. So for part A, have a coordinator here. We have a 0.5 kilogram particle at origin. So right here. A 1.25 kilogram particle at x equals to 0.15 and y equals to 0.2. So we'll be in the first quadrant. So it's about here and here. This object B, this particle A, and a 0.75 kilogram particle at x equals to 0.2 meter and y equals to negative 0.8 meter. So it'd be second quadrant. So 0.2 meter and it will be in the fourth quadrant. So 0.2 meter and negative 0.8 meter. So it's about right here. So C. And they ask for the center of the mass of the system. So for x coordinate, the x coordinate of center of the mass is equal to the sum of mass of each object times each object's x coordinate divided by their sum of mass. So x3 divided by m1 plus m2 plus m3. So, and then we plug in the numbers. We have 0.5 kilogram times 0 meters plus 1.25 kilograms times 0. So this is right here. So I just realized I drew the wrong diagram. There we go. So 1.2 kilogram times 0.15 meters about x coordinate and plus 0.75 kilograms times 0.2 meters and divided by their sum of mass. G plus 1.25 kg plus 0.75 kilogram. And after we do the calculation, we get a x coordinate of center of mass will be 0.135 meters. That's our x coordinate. And question B asks for the y coordinate. It's the same formula. So is m1 times y1 plus m2 times y2 plus m3 times y3 divided by m1 plus m2 plus m3. And then we plug in all the numbers to it. So it's 0.5 kilogram times the y coordinate, which is 0 meter because it's at origin. And the second one is 1.25 kilograms times the y coordinate, 0.2 meter, and plus 0.75 kilogram times negative 0.9 meters, and divided by their sum of mass, kilogram plus 1.25 kilogram plus 0.75 kilogram. And after the calculation, we get negative 0.14 meter. So the coordinate of the center mass will be 0.135 meters. negative 0.14 meters. Okay, part C. We have three objects sliced along the x-axis. So we only have x coordinate this time. So this is the x-axis. That means all their y coordinate is 0. So then so let's set here as origin. We have a 3 kilogram object. So right here is 3 kilogram. So this is object A. And object B is 2 kilogram at 1.5 meters. So here 1.5 meters. We have our object B. And a 1.2 kilogram object at the unknown position. So we have a unknown position. The center mass of the system three object is at x equals to negative 0.2 meters. So here is the center of mass. So it's most likely the object C will be on the left side of the region. So we have the part C, and we still use the same formula. It's the x coordinate of the center mass equals to the mass of A, which is 3 kilograms times coordinate is 0 because it's that region, plus second one is 2 kilogram times 1.5 meters, and plus that's xc. One is 1.2 kilograms, and divided by their, oh, my bad. So I should write the formula first. So I'm 1x1 plus I'm 2 x2 plus I'm 3x3. I'm 1 plus I'm 2 plus I'm 3. And then now we can plug in the numbers. So 3 kilograms times 0 meter plus 1. So 2 kilograms times 1.5 meters plus 1.2 kilograms times x3. So divided by the sum of their mass, 2 kilograms plus 0.2 kilograms. And we know the center mass of the system is negative 0.2 meters. And we solve for x3. So after the calculation, we have m3 equals to negative 3.53 meters. Okay, part D. How they okay, so this one is also only on the x-axis. So we have a glider A of 1.25 meters. So that's A. And the glider B And in the center here is the spring. So A is 0.125 kilogram and B is 0.5 kilogram. And we know A moved 0.96 meter to the left from the starting position. So to the left, 0.96 meters. And we still use and it asks for how far to the right does the glider be moved. So we still use the same formula. So CM equals to A x A plus B x B A plus B. And since x, the center of mass is gonna be 0, so we only have to calculate the numerator. So 0 equals to MA, which is 0.125 kilogram times 0.96 meters plus mass of B is 0.5 kilograms times XB, and we solve for XB. And after the calculation, we have XB, the B moved 0.24 meters divided by 4. Yep. Wait, there's something wrong. Oh, sorry. So since A is moving to the left, I forgot the negative. I feel like there's something right. Yeah, there we go. So it's 0.24 meters. Okay, so part E. So we have 3 objects. So we have object 1, of, say, okay, so we just say O1. The coordinate of it is negative L, 0, and object B is L, 0, and object C equals to 0, L. Yes, let me double check. So L, 0L, positive L, 0, and negative. Yes, so these are the initial position. And we can calculate the initial centimeter center of mass position. So the x coordinate equals to 1 x1 plus 2 x2 plus 3 x3 divided by 3 amps. Wait. Yes, because they have the same mass, so we can ignore the M1, M2, M3. So, and after we plug in the number, so 3m, so the first term is 0, the second term has so we have m l m negative my bad m times negative l plus m times l plus m times 0, and negative l and positive l, they cancels out, and 0 times m is 0, so the x-coordinate of center of mass is 0. So let's see the y-coordinate equals to y1 plus y2 plus y3 divided by 3m. And all the m's cancels out, so we have 3, so y1 equals to 0 plus 0 meters. Sorry. Wait, yeah, let's just use 0 because I don't think, yeah, it doesn't give the unit, so just coordinates. So 0 plus L. So the coordinate of the center mass will be L over 3. Okay, now we know the center of mass. So now we can calculate the position of object 3. So we have object 1 equals to negative L over 3, L over 4. Object 2 equals to L over 2, L. And object 3, we have x 3, y 3. Double check. Yes, okay. So we know the center mass is 0, so let's do the x-coordinate first. So x center mass equals to divided by, so is 1 x1 plus 2 x2 plus 3 x3 divided by 3m's. Oh, I forgot again, so these are the same. Okay, so now we're plugging in all the coordinates. So we have 3m, and the first one is m times negative 3 over L plus m times 2 over L plus m times x3 equals 0, because the x coordinate of the center of mass is 0, and all the m's cancels out, and divided by 3. That means, do not have to divide by 3 because it's 0, so only the numerator, so 0 equals to negative 3L plus 2 of L plus x3, so we can get x3 equals to negative of 6L. Oh, L over 6. And now we have the part ask for the y coordinate. The same thing. So center of mass equals to m y1 plus m y2 plus m y3 and 3 m's. Okay, and now we plug in a number. So the center of mass of y is what it was. Where is it at? Okay, so L over 3. So L over 3 equals 2. Let's see, 3 m's. M times y1, which is L over 4 plus m times y2, which is negative L plus y3. All the m's cancels out, and we times both sides by 3, so we have L equals to 4 over L plus negative L plus y3, and we solve for y3, which is equals to 4 over 7L. And that's it. Thank you for listening.